So let me talk a little bit about the looping thunder. Obviously, this thing is a roller coaster, right? And the idea of a roller coaster is that you start off with mgh, right, at the top of some elevation, right? And you might have a little bit of 1/2 mv squared, right? And then at any other given point, at any other given height, right, you have mgh. This is, you know, the height you start with, right? You have this mgh, right, plus 1/2 mv squared, right? And the cool thing here is that the mass stays the same, assuming nobody gets sick, right? And so you can figure out, if you know the original height, if this is the original, in other words, right here, you know, when they're right there, okay, if that's the original height, okay, and that's the original velocity, which we could guess to be maybe a meter per second squared, right? At any other height, we ought to be able to calculate this, right? Okay, so you can do this. There's a lot of things you can do, right? You can just make a model of this. Let me just go and show you this, right? Here we actually have elevation data, right? So here we go up, 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 up. Okay, and then I would ignore that little thing there, but here you've got an elevation there. You can read it off. It's about, what, 5 meters or something like that, right? And then you go up to here, right? And then you go down there. This must be the top of the loop, I'm guessing, right? So you could figure out what the velocity is here and here and here and here, right? What it should be using using the MGH and stuff that now has been erased because I just toggled, right? Okay, so that's one thing you can do, right? Another thing you can do is you can figure out the velocity of the car, right? You can put in a movie. Oh, let's go back to this thing too. This is pretty cool. Notice that it's this is our x is our axial. Our y direction is actually negative lateral, so it's g-force to the left, and then the z is actually vertical. And you can go in here and just say, okay, I only want to look at vertical, right? Well, here in the drop, there's tons of vertical stuff. In the loop, we actually go, do we go negative? That's a little crazy, right? Okay, so that's sort of interesting, right? We can look at axial acceleration, which would be our x. This is acceleration in the direction. Notice as we go up the hill, here we are going up the hill, there's some part of gravity that's acting against my chest because of the inclined plane, right? And then we can look at the y direction is our sideways. This is going around corners, right? And this is tricky because the corners are banked, right? So you can compare where you are in the ride with what the g-forces are, right? The other thing you can do is you can, I don't want to save. Let's see. I always have to talk to it, right? You can insert a movie. I've got a movie in here somewhere. Okay. All right, so here it is. Daddly da, daddly da. Oh, let's hit play. Another thing you can do is you can rotate the axes and do an acceleration curve as it goes down here. What is its acceleration, right? And I show you that in another video, right? And then here's another interesting analysis that people have done is right there, okay? They look at the velocity of this thing as it goes around. This is just a classic conservation of energy problem. Here it's got potential and kinetic, right? And then here, of course, it's got, you know, when it's right here, it's got more kinetic, right? Okay. And we think we know the length of one of these cars, so we ought to be able to figure out how high the loop is, right? And for a given elevation, we ought to be able to figure out, or at least at the top, we ought to figure out what its velocity is. We ought to be able to figure out through cleverness what the radius of this thing is, right? And then if we know that radius, right, if in this loop, right, if we know what this radius is, okay, then we know the velocity of the car as it's going there, right? The acceleration is v squared over r, right? Okay, so we can just do the tangential velocity there, right? And then of course we know that at this point it's what the ride pulls, what you feel and what you measure is what the ride pulls minus a g, right? Okay, so if this is say 10, or let's say it's 12 meters per second squared, right, then it's going to be 12 meters per second squared minus 9.8, right, is what you actually should read at the top of that thing. And you ought to be able to go back and look at vertical data especially in that one file that we were looking at, right? So lots of ideas for the looping thunder. Make a model of it. Do the acceleration down the curve. Figure out what the velocity should be at different heights.